like a Hellcat.
Hey guys, so welcome back sa ating YouTube channel. So ito na yung ating next chapter para sa ating abstract algebra 1. So in this chapter we will discuss about abelian and cyclic group. So I guess parang pang-apat na module na natin to. So ito na yung mga set of videos na kung saan ang pag-uusapan natin is abelian and cyclic group. So actually napakasaglit lang na itong abelian kasi almost na-discuss ko na siya sa mga previous lesson natin. So abelian is just the meaning of abelian is just a group which is the binary operation is commutative. Ayun naman yung ibig sabihin niya. Okay, so let's have the definition. So again, in this video pag-uusapan natin ito yung mga example niya. Okay, so the abelian group, so definition, a group G is said to be abelian, or G is an abelian group if the operation in G is commutative, and that is AX is equal to XA. So again, sinabi ko na yan. So AX is equal to XA for all A and X element of G. So napansin mo sir, medyo pareha siya ni centralizer sa center. Yes, tama yun. Ngayon, malalaman mong abelian. So dito may konting to, yun na, for all X. Otherwise, we say that G is non-abelian. So ngayon, malalaman mo, may connection ng pag-iang center sa ating pagiging abelian. So kunyari, nangyari, lumabas sa case mo na yung center of G is just equal sa G. Kumbaga nakuha mo lang is mismong set G o yung mga element ng G. Therefore, masasabi mo, therefore this implies that G is abelian. So tama naman. Bakit sir? Kasi ang mangyayari, yung isang element nagko-commute sa lahat ng element. Kumbaga kasi doon ginagawa natin sa center of G, check natin lahat ng element if nagko-commute siya. Ngayon, if that is the case na mangyari na lahat ng element niya nag-commute sa kanya o nag-commute sa kada element, so ibig sabihin yung center of G is equal to G, then therefore G is abelian. So pwede natin consider by conditional yan. Ngayon kung yung G is abelian, so kung aware ka na G is abelian, automatic C of G mo is equal to G. So tandaan mo rin yan. Ngayon wala yung connection sa ating centralizer kasi centralizer nagre-refer lang dun sa element. Okay, yung mga nagko-commute sa kanya. So tandaan yan. Okay, so now example. So ito yung the group, no? So again, example na ibibigay ko dito, wala akong masyadong i-highlight dito. So actually parang nasabi ko ito last time, no? So the group R, so ano ba yung mga lilista na sir? The group of real number, comma plus. So unahin ko lang ito mga to. The group of real number, comma plus is an abelian group. Next, the group of integers, comma plus is an abelian group. The group of rational number, comma plus is an abelian group. Also the group of n, comma z plus is an abelian group, are all abelian group. So ano ba spelling? So that is abelian group. Okay, so tandaan yan. So ito ay parang bawas na sa ating magiging kumbaga for example, may nakita ka, pinapahanap ko yung center ng r, comma plus. So without explaining, alam na natin yun. So sabihin mo na lang yung kanyang center of R. So center of R, comma plus o nung group na to is just the real number itself o yung buong real number. Okay, so example na NZ, comma 2, NZ, comma plus is example nito is si 2Z, comma plus. Okay, so ano yung element ng 2Z? So tandaan na ang element ng 2Z natin is the set containing that something, negative 2, 0, 2, 4, and that something. So lahat ng multiple of 2, comma plus. Andyan yung kanyang identity element na 0. So may inverse yan. Inverse ng 2 is negative 2. Commutative yan. So why commutative? Kasi yung 2 plus 4, so tanda mo, 2 plus 4 is same as 4 plus 2. Okay, so that is also element of 2Z or ng element ng group na yan. So tandaan yan ha. So again, bawas na sa magiging trabaho natin itong mga to. So tandaan itong ninote ni sir dito, no? Aware ako na sila ay abelian group, therefore yung center nila is yung mga set lang din sa loob ng group niyan. Okay, next is the symmetric group. So kung familiar ka, no, din symmetric group, kunin ko lang din ha. So yung madami ng notes, hindi ko na makakita. Okay, so kung napapansin mo, ito yung ating symmetric group. Okay, yung may epsilon, alpha, alpha squared, beta, beta alpha, beta alpha squared. So ang tanong, siya ba ay abelian? So kung papansin mo, yung center of C, yung center ng S3 natin, o yung center ng symmetric group natin is just the epsilon or the epsilon. So kung napansin mo, ito parang definition na to. So obviously, makukuha mo pag alam mo yung center nito. Okay, so since alam mo yung center nito is not equal mismo sa symmetric group, therefore hindi siya abelian. Okay, lagay ko lang since the center of S3 is just equal to the set containing epsilon or epsilon, which is not equal to S3. Therefore, or then S3 is not abelian. Okay, so is not an abelian group. Masyadong pangit yung is not an abelian group. Okay, so another case din siguro na pwede natin i-counter example para masabi natin na siya ay hindi abelian, aside sa center na yan sa sinasabi ni sir, pwede rin natin i-consider. So consider itong element na to. So consider alpha and beta alpha. Okay, note that beta alpha asterisk alpha is not equal to alpha asterisk beta alpha. So check na natin, tama ba yun? So alpha asterisk beta alpha, so magpas ako sa pagkakatupi. Ay, tama lang pala. Alpha asterisk beta alpha is beta. Okay, beta alpha asterisk alpha, beta alpha asterisk alpha is beta alpha squared. Okay, so therefore hindi sila equal. So since may nakita ko isang counter example, so yun sabi nga ng symmetric, sabi nga ng pagiging abelian. Abelian ka pag for all a and x. So meaning sa lahat ng element dapat sila commutative sa isa't isa. So since nakita ka ng isang element o ng pair ng element kung saan hindi sila nag-equal, okay, therefore hindi siya abelian group. Okay, so tandaan, S3 or the symmetric group is not abelian group. It's not an abelian group. Okay, so now let's move on to number 3. So C sub n comma plus. So obviously this is the addition modulo n or the group of addition modulo n. So obviously ito ay nabanggit ko last time. Note na ang kanyang center ng C sub n natin is just equal to C sub n. Okay, so therefore this is abelian. So the group C sub n comma plus is an abelian group. So tandaan, abelian group C sub n. So dagdag knowledge natin yan. Next is the line 4. So I guess hindi natin ito napag-usapan last time, no? So medyo binabalik-balikan ko lang na nire-recall ko lang kayo. So sulat ko lang tong ating ating client 4 group. So ano ba yung laman ng client 4 group? Ito ko lang lagay. So asterisk. So this is E, A, B, C. This is E, A, B, C. So ito yan, mga element na yan. Check natin, lagay na natin element. So sa notes ko, this is E, A, B, C, E, A, B, C. Okay, this is A, E, C, B. This is B, C, E, A. Then B, A, E. Okay, so note na observe natin, no? So hindi natin kailangan i-test kay epsilon kasi nga kay E hindi natin i-test lahat ng element kasi obviously siya yung identity element. Ngayon i-check natin kay A. So checking nito para malaman natin kung abelian. This is A. Okay, so ito yung A, no? So check natin. So sabi ko nga, no, kahit no need to test itself sa A. So test na lang natin sa A kay B. So A asterisk B is equal to B asterisk A. So check natin, no? A asterisk B is C. Okay, B asterisk A. So B asterisk A is C. A asterisk B is C, B asterisk A is C. So okay tayo dyan. Next, A asterisk C is equal to C asterisk A. Check natin. A asterisk C is B, C asterisk A is B. Okay, so check tayo ulit din. So therefore okay dyan. Then pagdating kay B, so we have B asterisk A is equal to A asterisk B, which is kaka-check lang natin. Next is B asterisk C is equal to C asterisk B. So check. B asterisk C, B asterisk C is A. Okay, C asterisk B is A. Okay yan. So, check tayo dito. So, last this is C. So, C asterisk A is equal to A asterisk C. So, na-check na natin yan doon. Next is C asterisk B is equal to B asterisk C, which is also na-check na natin dito. Okay, so, no need to check itself yung element na yan mismo sa ina lang kasi A, B lang yung pa-check natin. So, therefore, since alam natin na siya ay abelian or commutative sa kahit anong element, pair ng element, therefore, this group is an abelian group. So, the client for group. So, the client for group is an abelian group. Abelian group. Okay, so take note tayo dyan. Next is the group of non-singular 2x2 matrices under addition. Again, the group of non-singular matrix under addition. So, ito ba ay under matrix multiplication? So, ito ba ay abelian or not? So, we all know na sa matrix multiplication, this is not commutative, no? From linear algebra, like ko na dito, no? So, note lang. Note from linear algebra. So, from linear algebra, okay, so from linear algebra, we all know that AB multiplied by B, A multiplied by B is equal to B multiplied by A is not equal. Okay, so yung matrix multiplication is not commutative. So we all know that matrix multiplication is not commutative. Okay, so therefore yung group na to, so the group na to, so paano ba isulat to? So pag sinulat natin yung group na yan, this is just itsura na ito. Wait lang, kunin ko yung itsura nya. Yung group na ito. Ito lang sa group. Okay, so ito ay GL2F. So itsura, ang pangalan kasi nito is GL2F. Okay, so ano ibig sabihin yan? Group of linear algebra, tas 2x2. So, kung napalit ako ng 3, so 3x3 matrices yan. Okay, so itong GL2, F is not an abelian group. Is not an abelian group. Okay. Okay, so next is for number 6. So, again, balikan natin itong mga to. So, tandaan. So, the group of R, plus Z, plus Q, plus N, Z, plus is not an abelian group. Is an abelian group. So, ano ba yung dadagdag natin pwede dito? So, nadagdag ko data last time ng R asterisk. No, R asterisk, multiplication. So, ito ay also abelian group. Kasi multiplication is commutative. Okay, under real number. So, totoo yan. Then another is yung Q. So yung Q asterisk. So ito yung walang zero, no? Is also an abelian group or commutative lahat ng element dyan. Kasi 1/2 times 1/4 is equal to 1/4 times 1/2. Okay, so tandaan yan. So next is number 6. Ito proving problem. So sorry, medyo ito lang yung nilagay ko. Wala kasi ako makita talaga totally. Kasi more likely kasi si abelian is ginagamit as part ng proving. Kumbaga, pag nabasa mo abelian, automatic A, X, AX is equal to XA. Ganun mo agad isipin. Or AB is equal to BA. Ay, ganun yung mga kinoconsider dito. So now, let's have number 6. So prove that a group G is abelian if and only if AB inverse is equal to A inverse, B inverse. So the word itself may if and only if doon. So therefore, this is case 1 and case 2. Or yung papunta, okay, then yung converse. Okay, yung implied, then yung converse. So proof, para natin siya ipoproof or ipoprove. So ito yung proof, no? So proof natin yung papunta. Okay, so para sa papunta, okay, so ang assumption natin, G is abelian. Okay, G is abelian, then we have AB is equal to BA for all AB and B element of G. So aware tayo na G is abelian, then AB is equal to BA for all AB element of G. Sir, hindi X. Okay lang naman kahit ano, basta alam naman natin na is for all yan. Okay, so now, consider natin tong AB inverse is equal to A inverse B inverse. So, consider ko lang si AB inverse. Okay, so by Saxo theorem, this implies that this is B inverse A inverse. Okay, by Saxo theorem, this implies that this is B inverse A inverse. So, or pwede ko na palang gawin yun sa loob doon, no? Kung napansin nyo, AB inverse. So, by property ng abelian, since G is abelian, pwede ko nang gawin BA. Tama, pwede ko nang gawin ganun. So, para mas madali, para hindi na ako mag-manipulate. Again, since sabi nung ating assumption, AB is equal to BA, therefore, AB is just equal sa BA inverse. Okay? Then, by Saxo theorem, this is just A inverse B inverse, which is ayun na yung goal. So, nangyari, AB inverse is equal to A inverse B inverse. So, tapos na tayo. Mas napadali yung ginagawa ni Sir. So, next is yung ating pabalik. So, ang assumption natin is AB inverse is equal to A inverse B inverse. So, ito yung assume natin. Okay? So, consider natin si AB. So, kailangan masabi natin na siya ay inverse, abelian. So, consider si AB. Okay, consider natin si AB inverse. So, I guess ganito na lang. Consider si AB inverse. So, alam natin na siya ay element of G for all A and B. So, kung yung A and B element of G, therefore, yung AB o yung, therefore, close siya. So, meaning yung AB element of G. So, alam natin na group siya. Then, this implies na si AB inverse is also an element of G. So, by definition of inverse, kung andyan yung A, andyan din yung A inverse. So, kung andyan yung AB, andyan din yung AB inverse. Now, by assumption, this is just equal sa A inverse B inverse. So, kasi ito yung assumption natin. Sa taas ng yan. Okay, ngayon, ano ba goal natin? Ang goal natin is mapalabas natin na AB going to BA. Now, by Saxo theorem, this is just BA, tapos lalabas yung inverse. Okay, and also, we all know na saan galing to. Yung BA inverse, galing kay A inverse, B inverse, which is galing kay AB inverse element of G, which is galing kay AB. Meaning, etong nangyari to, nagmanipulate lang tayo, element pa rin siya ni G. So, since element siya din G, therefore, by definition of inverse itself, yung BA is an element of G. Kasi, kung andyan yung inverse, nandyan yung mismong element, which is BA. Therefore, AB is equal to BA. So, G is abelian. Okay, therefore, this is done. Okay, so tandaan yan. Ngayon, meron tayo itong remark. So, if G is a finite group, then G is abelian if and only if the group table of G is symmetric. So, ano ba ibig sabihin ng group table of G is symmetric? Mapapansin mo naman sa salansang ng element, no? Okay, so, another thing para masabi mong symmetric is something na, pinaka-hint ko lang, no? Nasa diagonal side yung E, yung identity element. Okay, so napansin mo yung E identity element. Tapos ano yan, symmetric kasi A dito, A doon, B dito, B doon, C dito, C doon. So C to, C doon. Okay, A to, A doon, B doon, B, then E. Okay, so sa lansang. So I guess isa sa mga criteria na sinasabi na to is para masabi mo symmetric group, lalo kung finite yung pinag-uusapan natin, is check mo lang yung diagonal. Kung andun yung identity element lang, more likely siya ay abelian. Okay, so for example, kunin natin si C sub 4, plus. Okay, so check natin si C sub 4, plus. Paano ba natin mako-consider na siya ay abelian? So C sub 4, plus. Okay, so group table niya. So this is plus, addition modulo. So yung element lang niya is just 0, 1, 2, 3. This is 0, 1, 2, 3. Okay, so add lang natin, no. So this is a 0, 0, 1, 2, 3. So check natin kung tama yung sinabi. Pagkakaintindi ni sir. 1, 2, 3. This is, hindi nag-0. So this is 2, this is 3, this is 0. This is 3, this is 0, this is 1. This is 0, this is 1, this is 2. So, tapasin nyo, no? Sir, hindi naman lagi. Yes, tama, no? Hindi naman lagi pala na ganun. So, I guess, so, tandaan nyo, mali yung nabanggit ni sir na kung yung E nasa gitna o diagonal, abelian siya. So, pero alam natin na C sub 4, plus is abelian. So, I guess yung sinasabi na symmetric dito is yung salansang ng element. So, kung pansinin mo, dito ay pansin, ito 1 dito. Okay, 2, 3. Okay, balik na tayo sa gitna. Okay, so punta tayo dito banda. 3 parehas to. Parehas 0, parehas 1. So pansin mo no, tong part na to 3, 3, 0, 0, 1, 1. Okay, 1, 1, 2, 2, something na ganun. Okay, so yun yung pagiging symmetric para iniisip. So X tayo doon sa sinabi ni sir na yung E yung gitna o yung identity element. So wag nyo nang i-disregard nyo yung nabanggit na sir. So mali ako nang na-conclude. So di ko na rin kasi maalala yung property na yan. Okay, so that's all for this video. So hoping namin natutunan ka. Then sabi ko nga sa inyo, napakaikli lang ng video na to kasi nga pag-uusapan na natin yung abelian. So sa next video, pag-uusapan natin yung special type of group which is the cyclic group. So ano ba natin masasabi na siya ay cyclic group. So again, iba yung cyclic group sa pagiging abelian. So thank you for watching. Hoping na nag-enjoy ka.